So if I was you, I would probably write it out on another piece of paper with me, but it's up to you. Let's see what we're going to do. So our example. So the ambiguous case of the sine law, part 1. So workbook, page 195. I'm going to work on example 1. And it says solve triangle ABC if A equals 44.3 degrees, side A equals 11.5 meters, and side B equals 7.7 meters. Okay? So I'm not going to use the sheets that they're giving me. I'm going to do it on another piece of paper. Okay, so to be honest with you, I don't even know if a triangle can be made here. All I know is they're giving me this information. So I'm going to assume a triangle can be made, and that assumption is going to be shown by me actually drawing a triangle. So I'm assuming a triangle can be made, and here I go, drawing my triangle, la-di-da-di-da. The information that they're giving me is 44.3 degrees. They're telling me that this is 11.5 meters, and they're telling me that this is 7.7 meters. If I put B here, I have to put A here because that was the angle that they give me, which means that that'll make C up there. It wouldn't matter if I had put B up here and that had become 7.7. It would just be the same as turning that triangle around, so it doesn't matter. Look what we've got. I've been given a side, an angle opposite the side, and another side. That means that I'm going to go for this angle using the sine law. Okay, so it's going to be sine B over 7.7 equals sine 44.3 over 11.5. So the sine of this over that, sine of this over that. Rearrange it. It's going to be sine B equals 7.7 sine 44.3 over top of 11.5. Now I'm going to do all of this in one step. I'm then going to get angle B. So watch, I'm going to save myself some time. I'm going to start with sine of 44.3 times 7.7 equals, and then I'm going to do divided by 11.5 equals, and then I'm going to do second function, inverse sine, for my answer. And I goofed up because my calculator does things funny. What happened was we have a, let's do that again. It's going to be 7.7 times sine of 44.3. What happened before was with my calculator, it did 7.7 times the 44.3, then signed it. So I need to make sure that I know how my calculator works. I'm going to hit equals, divided by 11.5. So it gives me this value. Second function inverse of that answer is going to give me 27.8. So about 28 degrees. And that's all you have to show me. I don't need to see anything else. That's good enough. That's one answer. Another answer is angle B equals 180 minus 28, which is going to be 180 minus 28, so that's going to be 152. So we have two answers here. So there's a possibility of two triangles. A possibility. Let's see if it's going to work out. My first triangle will look like this. We're going to have 44.3. We're going to have 28. And if these two together add up to something less than 180, I'll have something to put up there. So that's 11.5, 7.5. Let's see. I've got 44.3 plus 28. They add up to 72. So if I have 180 minus 72.3, that leaves me with 107 degrees, 0.7 for that angle. So that's A, that's C, that's B, and I've made a triangle. Now it's not to scale, but that's my first triangle. Let's see if a second triangle is possible. Well, if a second triangle is possible, it's going to look something like this. Now that's pretty big. Let's bring that down. And again, it's not to scale, but this would be 44.3. And this one would be 152. Now notice what happens when I add 152 and 44.3. I get 196. Way too big. I've got nothing up here to put in there. 196 is larger than 180 degrees, and the interior angles of any triangle drawn on a flat piece of paper must be 180 degrees. So, no triangle possible. Only one triangle is possible with this information. And if you wanted to have a reason for this over here, what you would say is 44.3 plus 152 is greater than 180 degrees. And that is the angle, what's it called? Angle sum of a triangle theorem. So angle sum of a triangle theorem, ASTT is the short form for that. So it ain't going to work. There's nothing left over for this angle. And what you would do then is just finish off this triangle if you were told to solve and come up with C. So coming up with side length C, you'll simply do C over sine of 107.5 equals 11.5 over sine of 44.3. You're going to solve that. So it's sine of 107.7 times 11.5 over top of sine 44.3. And again, I don't need to see anything else. So it's sine of 107.7, going to close the brackets, times 11.5 equals, divided by sine 44.3, close the bracket, equals, and I'm coming up with sine equaling approximately 15.7 units, whatever those units are. If this is meters, then that's meters, and this will be meters. Okay, so that's example 1 off of workbook page 195. Only one triangle was possible, and we solved for it. I'll come back with the next one.